Okay, so to get ahead of tomorrow's class, I just want to quickly explore this function, s of x, which we will make use of extensively in class tomorrow. It's not sort of function that we've seen much before. This is a function of a conic section, and we're going to have to use a table of values here to explore it. So I've set ourselves up with a table of values, and we're going to try each of these one by one to slowly build our argument here. So starting with s of -2. Note that this gives me the square root of 1 minus -2 squared. That is to say, the square root of 1 minus 4. That is to say, the square root of -3. And I can't take the square root of a negative number, so there's no real answer there. And -2 actually can't be in the domain of our function. So we have some restrictions on the domain of this s of x. Let's try -1. Then I get the square root of 1 minus -1 squared, which is to say the square root of 1 minus 1, which is to say the square root of 0, which is just 0. So that works just fine. I can take s of -1 and I get 0. -1 is actually the smallest number I can take s of. Everything below -1 is not in my domain. Okay, let's try s of -0.8. That's equal to the square root of 1 minus -0.8 squared. -0.8 times -0.8 is positive 0.64. 1 minus 0.64 is 0.36. And the square root of 0.36 is 0.6. So when I use -0.8 as my input, I get 0.6 as my output. If I take s of -0.6, it's like basically what I just did, kind of reversed. Now I have 1 minus -0.6 squared. That is to say, I have the square root of 1 minus 0.36, which is the square root of 0.64, so it's 0.8. When I take s of 1, it's actually pretty darn simple. Sorry, s of 0, I mean. S of 0 is the square root of 1 minus 0 squared, which is the square root of 1, which is 1. And by similar arguments, you can see that s of positive 0.6 is 0.8, s of positive 0.8 is 0.6, and s of 1 is 0. If I try to take s of anything bigger than 1, it won't work. That is outside of my domain. Overall, then, this is what my graph looks like. I have a point at -1, 0. So let's use this as our point, -1, 0. I have a point at 0, 1. So let's use this as my 0, 1. And then I have a point at 1, 0. I have a point at -0.8, 0.6, which is like there, and a point at -0.6, 0.8, which is like there-ish. Likewise, I have points here and here. If I carefully construct these and draw what I'm looking at, this is the shape that I should end up with. I get what is actually a perfect semicircle. That's why we called this thing S. It is the graph of a semicircle whose radius is 1. So every point on here is 1 unit away from the origin, point 0, 0. So we'll take a look at this semicircle graph, this s of x, in many of our examples tomorrow.
Hopefully that'll go okay for us. I will see you then.